The cold bit hard that morning. A thin mist crawled over the runway at the Luftwaffe's test center in Rechlin, turning the landscape into a silent grey sheet. Engineers in heavy coats gathered around a single aircraft parked in the center of Cove. The field, a strange, almost fragile-looking machine. The Luftwaffe had spent months trying to bring down intact. It was a British Mosquito, a wooden bomber that had slipped through German radar nets, outrun interceptor squadrons. Embarrassed some of the Reich's most trusted commanders. Now, at last, Germany had one in their hands. A prize. A puzzle. A phantom made of plywood. Teams from the Luftfahrtforschungsanstalt moved in carefully, as if approaching something alive. Their orders were simple. Tear it apart, and explain how a wooden aircraft could outrun the Bf 109, outclimb the W190, and deliver precision strikes on targets deep inside the Reich. The Mosquito had become a rumor, a ghost, a humiliation. But today it was real and silent in the frozen November air. The engineers began removing the first panels. They leaned in, expecting crude joints, hammer marks, the simple logic of wartime carpentry. Instead, the moment the fuselage cracked open, several of them stepped back in surprise. Interior wasn't rough, it wasn't primitive, it was seamless, beautiful. A wooden shell blended with adhesive so advanced that a few engineers whispered they might have been looking at the work of an entirely different industry or an entirely different country. Then came the moment no one expected. As the first stress tests began, as the clamps tightened and the panels flexed under controlled pressure, something unbelievable happened. The wood started to split. The plywood layers began to shear. But the glue wouldn't fail. One engineer wrote later that the adhesive held as if it were metal. Another said it surpassed some steels in sheer strength. In a war defined by factories, alloys, and riveted armor, a wooden British aircraft had arrived in the heart of Germany and introduced a new fear. The enemy had out-engineered them with plywood and chemistry. The dissection had only just begun. Long before that, Mosquito landed at Rechlin. The aircraft had already built a reputation inside the Reich, a reputation no one wanted to admit was real. The first warnings came from night fighter crews over the Ruhr reports trickled in during the spring of 1942. Fast, unpainted aircraft, impossible to catch. At first, Berlin dismissed it as pilot exaggeration. Wooden aircraft didn't outrun fighters. Wooden aircraft didn't climb like that. Wooden aircraft certainly didn't slip through radar nets. Like smoke. But the sightings didn't stop. One Luftwaffe radar station near Essen reported a contact that blazed across the screen for only a few seconds, before vanishing as if the operator had imagined it. A week later, a reconnaissance post near Bremen spotted what they described as a ghost-colored twin-engine aircraft flying so high and so fast that none of their defensive fighters could make an interception attempt. Interceptor squadrons scrambled, engines roared, but the Mosquito climbed away easily, its twin Merlin engines singing an almost mocking tone as it disappeared into the clouds. Each time the Luftwaffe filed the same frustrated report. Unable to engage, the Reich Ministry of Aviation didn't like these reports. Hermann Göring hated them. The Mosquito's daylight raids, always fast, always precise, humiliated him in ways no bomber had before. After one low-level attack on 2ND, Berlin's Haus der Rundfunks Göring famously complained to his staff that it was unfair, that wooden airplanes were making fools of his metal-forged Luftwaffe pressure built inside the intelligence sections of the Oberkommando der. Luftwaffe officers were ordered to analyze every detail, every scrap of information. How was a bomber made of plywood performing like a next-generation fighter? Engineers offered theories. Maybe the British had perfected some exotic lightweight alloy. Maybe the aircraft was mostly steel under thin wooden skin. Maybe it used magnesium frames, radical aerodynamics, or an experimental laminar flow concept. But no one could explain how its radar, the signature was so faint, no one could explain why the structure didn't shake apart at high speeds. No one could explain how a wooden fuselage could stay rigid under combat maneuvers that left metal aircraft creaking. As the confusion deepened, one thing became clear. Germany didn't understand the Mosquito, and anything a nation doesn't understand it fears. So when word arrived in late 1943 that a Mosquito had finally been forced down nearly intact, the mood in the Luftwaffe changed. Instantly, test pilots at Rechlin expected a miracle of metallurgy disguised as wood. What they found was something else entirely, something they weren't ready for. The moment Germany realized they had a Mosquito on the ground, intact enough to study the message, traveled through the Luftwaffe like a spark hitting dry tinder. The aircraft had been operating near the Dutch coast, a reconnaissance variant, sleek and unarmed, relying on speed to survive. But that day, bad weather rolled in unexpectedly. Ice began forming along the leading edges. The pilot struggled to maintain altitude. A chain of desperate decisions followed, and the Mosquito descended lower and lower until it finally skimmed over the treetops. Somewhere near the outskirts of a Dutch village, the aircraft touched down hard. It wasn't a crash so much as an exhausted landing, the final slide of a machine that had nearly made it home. The crew escaped, but the aircraft remained mostly whole. A German patrol surrounded it. Quickly, soldiers approached with rifles, raised half expecting mines or traps. Instead, they found a silent wooden machine, smooth, almost elegant, resting in a muddy field. One soldier reportedly tapped the fuselage with the butt of his rifle, expecting the hollow sound of thin plywood. Instead, he heard a deep, tight thud, solid, strong. Not at all what the Luftwaffe had come to believe. Orders came rapidly. Do not damage it, guard it, transport it immediately. Within hours, trucks arrived. Mechanics and officers swarmed over the aircraft, wrapping it in protective canvas, lifting it onto reinforced trailers, and escorting it with armed convoy vehicles. Villagers along the roadside whispered that the Germans looked almost nervous, as if the wooden creature they carried might wake up and fly off again. It arrived at the Luftfahrtforschungsanstalt, the Rechlin test center under heavy watch. Engineers and officers gathered as the Mosquito rolled into hangar. 5 floodlights cast long shadows on its curved plywood skin. Some men stood in silence, studying it like archaeologists who had just uncovered something old and dangerous. At first glance, they noticed the absence of rivets, the sleek curves, the clean lines. Something about it felt wrong, or rather impossibly right. They had anticipated crude wartime craftsmanship, a stopgap, a cheap plywood bomber, but standing close to it, they realized just how mistaken that assumption had been. The real surprise came when they lifted the nose section. They expected a metal subframe, some kind of hidden skeleton supporting the aircraft. Instead, they found almost none. The Mosquito was not a wooden shell wrapped around metal strength. The wood was the strength. One engineer reportedly murmured, "This is not carpentry. This is architecture." The test director ordered the aircraft to be stripped carefully, every bolt catalogued, every joint photographed. The Germans had wanted this for months, and now it was here, ready to be cut open, dissected, understood. But as soon as they began opening the fuselage, the mystery deepened. There were no traditional wooden ribs, no lattice of beams holding the shape. Instead, they found a monocoque shell, layers of birch and balsa formed in molds with a precision. None of them had associated with Britain's wartime industry. Some engineers looked confused, others looked quietly impressed. A few looked almost uneasy, because this wasn't something they could dismiss anymore. This was a weapon built by a nation that understood wood in a way Germany didn't. A weapon built by furniture makers, piano factories, and craftsmen who had turned their skills into aviation engineering. A weapon that seemed fragile until you touched it. Germany finally had the Mosquito they wanted. What I didn't know yet was that it would only deepen the humiliation. The hangar doors groaned shut behind the engineers as they began the work. Germany had waited over a year to perform. Lamps were wheeled into place, workbenches filled with calipers, clamps, micrometers, magnifiers, and notebooks. The Mosquito sat at the center, like a patient on an operating table, silent, stripped of engines, but still carrying the aura of something dangerous. The first cuts were careful, deliberate. Fine-toothed saw slid through the outer skin of the fuselage far more smoothly than expected. Instead of splintering, the blade moved as though it were cutting through dense uniform material. The Germans paused. That wasn't normal plywood behavior. They widened the incision, and that was when everything changed. Inside, they expected to find ribs and spars running like bones through a body. Instead, they found almost nothing. The Mosquito's fuselage was a hollow, seamless shell, a torsion box. The strength wasn't in the purrs. Framework. The strength was the shell itself. Two engineers exchanged puzzled glances. Another leaned in and touched the cross-section with the back of his knuckle. Layers perfectly bonded. Layers of birch, balsa, and birch again, forming the sandwich structure that behaved more like a single molded piece than separate components. The curves weren't decorative. They were structural, each subtle arc, distributing stress across the whole body like a drumhead or a finely carved violin. One of the German engineers, a man who had spent his life working with aluminum skins and riveted frames, whispered almost to himself, "This is not wood. Not as we understand it." They sketched measurements, thicknesses, grain directions, bonding angles. But the more they studied it, the more questions emerged. Why did the internal structure barely exist? Why did the shell resist twisting stress tests that should have shattered wooden components? Why was the entire aircraft designed like one enormous molded piece of furniture? As they worked deeper into the airframe, they discovered innovations that didn't appear in any Luftwaffe design manuals. Sections molded by giant female form molds, contours intentionally shaped to create stiffness without adding weight, wooden panels joined without nails or screws, instead relying on adhesives so flawless that the seams were almost invisible. Germany's obsession with metal alloys welding rivets had blinded them to this possibility. Plywood had never been treated as a miracle material. It was for crates, toolboxes, and emergency gliders. But here in front of them was plywood, behaving like high-grade aerospace material. The more pieces they removed, the more respect grew quietly among the engineers. Not admiration, they couldn't admit. That, but something close to it. The Mosquito had humiliated them in the sky, and now it was beginning to humiliate them in the workshop. They moved toward the wing roots. Normally, wings attached to the fuselage through heavy metal fittings. The Mosquito used long, continuous spruce spars that blended into the fuselage joints with immaculate precision. No massive steel brackets, no complex mechanical interfaces, just brilliant woodworking that distributed load without creating stress points. One engineer wrote in his notebook, "This is the work of craftsmen, not factory laborers." They kept cutting, opening, measuring, and the shock only grew. They weren't looking at low-tech improvisation. They were looking at the result of a nation that knew exactly what it was doing. But the greatest surprise, the one that left them baffled, unsettled, and eventually almost ashamed, was still hidden inside the bonded seams, a secret no one in the Luftwaffe expected, a substance so strong that it would force engineers to re-examine everything they believed about materials, aircraft, and the future of aviation itself. And soon, they would find it. The moment the engineers began testing the Mosquito's joints, everything they thought they understood about wooden aircraft collapsed. It started with simple curiosity. They cut several samples of the fuselage, thin strips of birch balsa, birch composite, each still bonded with the original British adhesive. The plan was routine. Apply shear force record when the bond failed. Compare results with known casein glues and urea formaldehyde resins used in German wooden prototypes. They placed the first strip into the test rig. The clamp tightened. The gauge needle rose. And every man in the room leaned in. At a load where the traditional wood glue would normally crack the Mosquito sample, didn't react at all. The needle climbed higher, then higher. The wood fibers started to groan softly, that dry, splintering whisper only carpenters recognize. Suddenly, with a sharp snap, the strip failed. But the adhesive joint remained intact. The wood had broken around the glue, not at the glue. Silence washed over the workshop. One of the senior engineers frowned and ordered the test repeated. So they did. And again, the wood fractured, but the adhesive seam stayed solid. They increased the load on a third strip, pushing the apparatus near its limits. Same result. The wood failed long before the glue bond did. This was not casein glue, not milk protein, not urea. Resin. Not anything Germany used in its own wooden aircraft. Someone muttered, "Unmöglich," impossible. To understand the adhesive, the engineers shaved off a thin bonded layer and subjected it to heat tests. Normally traditional glues, softened or bubbled when exposed to elevated temperatures. But the Mosquito's adhesive barely reacted. Even at temperatures approaching the heated skin of an aircraft cruising hard, the bond remained stable. Then they exposed samples to moisture and humidity cycles. Again, nothing. It was as though the adhesive ignored the rules that governed every wood joint Germany had ever made. Finally, one of the chemical analysts spoke what others had only begun to suspect. "This is synthetic, something new, something we do not have." They were looking at aerolite, a revolutionary British adhesive, a cold-setting phenol formaldehyde, resin engineered specifically to withstand stress, heat, moisture, and vibration. Combined with Redux, an early structural bonding adhesive, the Mosquito's glued joints behaved like metal fillets rather than wood glue. In internal notes, one German chemist wrote, "The British have turned glue into a structural component." Tests continued for hours. They bent panels, twisted them, introduced stress at angles the Mosquito would never experience in flight. In nearly every case, it was the wood, not the adhesive, that gave up first. One engineer compared the bond strength to certain grades of steel fasteners, a phrase that circulated around the workshop until it morphed into the now legendary expression, "The glue is stronger than steel." It wasn't literal steel plate, of course, but in practical shear and tension tests used for aircraft joints, the Mosquito's adhesive outperformed mild steel fasteners used on many German designs. And that, the realization cut deeper than any knife the engineers had taken to the aircraft. Because Germany couldn't replicate it. Not under wartime strain, not with shortages, not with chemical supply chains collapsing under Allied bombing. What Britain had achieved wasn't luck, it was chemistry, industry, and craftsmanship working together in perfect sync. The Mosquito wasn't just a wooden aircraft. It was a wooden aircraft held together by science Germany didn't have. And that reality, more than the speed, more than the climb rate, more than the radar signature, was the moment the Luftwaffe understood they were facing something they couldn't match. But still they tried, and the attempt would end in disaster. The discovery of the Mosquito's construction, the molded plywood, the bonded layers, the glue that refused to fail, sent a shock through Germany's aviation hierarchy. Within days, Berlin issued a new directive. If Britain could build a high-performance wooden aircraft, then Germany would build one too, and build it fast. This desperate idea became known inside the Luftwaffe as the Holz-Knot program, the Wood Emergency Program. On paper, looked simple. Germany had forests. Germany had skilled woodworkers. Germany had world-class engineers. But what Germany did not have was the one thing that made the Mosquito possible. An industrial ecosystem built around precision, woodworking on a national scale with adhesives that behaved like industrial metals. Still, the order came down from above. Create our own Mosquito. The project eventually converged around a new aircraft, the Ta-154 Mosquito, designed by the brilliant Kurt Tank of Focke-Wulf Tank, was confident he could match Britain's concept he had done miracles with. The Ta-190. He understood aerodynamics, structure, and speed better than almost anyone in the Reich. But from the first day, the Ta-154 was sabotaged by one thing. Germany didn't have the glue. The Mosquito's aerolite and Redux adhesives were chemically advanced phenolic resins that cured predictably remained stable under heat and bonded with a strength that behaved almost like metal Germany's woodworking industry. On the other hand, relied heavily on casein glues made from milk protein, which weakened under moisture, temperature changes, and time. The Luftwaffe demanded a replacement. Chemists scrambled, and Dynamit AG, a chemical company under pressure to deliver results yesterday, rushed out a substitute adhesive, known internally as Good Luck One It, was a disaster waiting to happen. The first TAR 154 prototypes showed promise. They were fast. Agile, sleek Kurt tank even managed a test flight that impressed observers. But then, structural failures began slow. At first, subtle, easy to deny. A wing joint here, a panel separation there. Then came the catastrophic moment. During a high-stress landing test, the TAR 154's gear touched down, and the main spar failed. Not due to design, not due to wood, but because the glue itself was corrosive, eating into the wood fibers and weakening them. Over time, Germany's emergency adhesive didn't just underperform. It destroyed the very aircraft it was supposed to hold together. When engineers tore apart the failed Comstaments, components they found blackened, degraded wood. The glue had chemically attacked the fibers, almost like rot accelerated by heat. It was the opposite of the Mosquito's flawless bonding. As reports came in, Kurt Tank grew furious. The Luftwaffe grew embarrassed. And Berlin realized far too late that advanced wooden aircraft couldn't be improvised. They required the chemistry Britain had spent years perfecting long before the war began. The TAR 154 program limped forward a little longer, but the failures kept piling up. Germany tried to redesign, to strengthen, to patch. But nothing worked because the core ingredient, the miracle adhesive, did not exist within the Reich. In the end, the TAR 154 was quietly abandoned, a project born from desperation killed by chemistry. As German engineers watched their wooden prototype crumble under the strain of flight tests, a bitter truth settled over them. They had dissected the Mosquito completely. They had measured every angle, every joint, every curve. They had studied its structure, its aerodynamics, its weight distribution, but they could not copy its heart, because the Mosquito's strength didn't come from wood at all. It came from the glue, a substance Germany simply couldn't manufacture under wartime pressure, and without it, even their best efforts disintegrated. By early 1944, the atmosphere at Rechlin had shifted from curiosity to quiet resignation. The months spent dissecting the Mosquito, testing adhesives, and attempting to reproduce its construction drained resources and morale alike. The final report from the Luftfahrtforschungsanstalt was blunt and unsettling. British craftsmanship, it stated, was decades ahead of German wooden aircraft engineering. Some engineers, once confident in Germany's industrial might, began to voice what had become an unspoken truth. The Mosquito was a non-replicable solution, a product of industrial specialization, chemistry, innovation, and a civilian woodworking industry transformed for war. It was no longer simply an aircraft, it was a symbol of Germany's failure to adapt. At a closed-door meeting, a senior engineer remarked that while Germany was manufacturing aircraft with riveted aluminum skins and steel frames, the British were forging weapons from plywood and glue, materials dismissed by many German experts as inferior. One officer, long a skeptic of wood as a structural material, lamented, "We have been out-woodworked." The Luftwaffe command, desperate for answers, tried to innovate with alternative materials and adhesives. But the chemical plants were bombed, raw materials were scarce, and technical knowledge was limited. The British had set a standard they could not meet. Even more painfully, the Mosquito continued to fly and fight with impunity, evading interceptors, carrying out deep strikes, and performing reconnaissance missions that exposed German secrets. For German pilots and ground crews, the Mosquito was a ghost. They could not catch a ghost that mocked their every effort. In reports back to Berlin, engineers admitted defeat not with fanfare but with a weary pragmatism. We cannot compete with the Mosquito's design. Our attempts to replicate it have failed. Our only hope is to develop better radar and interception tactics. But even those tactics failed. More often than not, In the closing chapters of the war, as Allied bombers roared over German cities, the Mosquito remained a persistent nightmare. Fast, precise, and seemingly untouchable. For German engineers, it was a bitter lesson. Sometimes innovation comes from unexpected places, from plywood glue and craftsmanship, and not from raw steel or heavier weapons. The wooden phantom had out-engineered them, and Germany had nowhere left to turn, even as the war's tides turned against Germany. The Mosquito's shadow only grew larger. It became more than a bomber, more than a reconnaissance plane. It became a symbol of Allied ingenuity, a reminder that innovation was not bound by raw materials or tradition. Inside German command centers, every Mosquito sighting triggered alarm bells. Briefings detailed its uncanny ability to slip through defenses, hitting critical targets by day or night. No interceptor pilot claimed a reliable kill against it, without heavy losses. Its missions were surgical, its strikes precise. Allied commanders trusted the Mosquito to gather intelligence behind enemy lines, photograph installations, and return safely time and again. Even as Berlin's defenses tightened, the Mosquito kept slipping through. Radar operators called it the wooden ghost. Some believed it had special coatings to evade detection. Others whispered of secret engines. But the truth was simpler yet harder to counter. The Mosquito's blend of speed, altitude, and unmatched structural strength made it almost untouchable. Throughout 1944 and into 1940. 5. The Luftwaffe scrambled every resource to counter it. Jet fighters improved night fighter tactics, radar upgrades, but none succeeded in fully neutralizing the threat. The wooden aircraft had become a ghost that refused to die. Post-war, the Mosquito's story became legend, a case study in how materials once deemed obsolete could rewrite the rules of warfare. Engineers and historians still marvel at the Mosquito's glue, its wood laminate design, and how a country's civilian industries pivoted so dramatically to serve the war effort. The Mosquito's legacy is clear. Sometimes the greatest weapons are not those made from the strongest metals, but those made with vision, innovation, and the courage to challenge convention. Germany never solved the Mosquito, and that failure in many ways sealed the fate of the Reich's skies. In a war dominated by steel, fire, and roaring engines, it was a wooden aircraft, held together by glue, stronger than steel, that haunted the skies over Germany. The Mosquito was not a mistake. It was not an accident of war. It was the product of vision and innovation, forged in the workshops of Britain's peacetime industries, turned to the needs of conflict. Germany, a nation proud of its metal engineering and industrial might, was caught off guard. The wooden phantom exposed the limits of traditional thinking. It revealed how war is not just won by might, but by creativity, adaptability, and daring to use materials others discard. As the last echoes of the Mosquito faded over the shattered cities of Europe, its legacy endured a lesson that innovation sometimes comes wrapped in the most unlikely forms. Wood and glue had defeated steel. Craftsmanship had outmatched mass production. A phantom made of plywood had changed the course of aerial warfare. And even today, the story of the Mosquito's glue, stronger than steel, remains a testament to the power of human ingenuity when pressed to the edge.